Okay, so welcome sa part 2 ng ating video lecture series about sa area movement method. Okay, so sa video na ito, i-discuss natin kung paano kumuha ng sumusunod. Una, slope. Okay, sa isang point. Pangalawa, deflection. And meron tayong isang bonus, syempre, if we're dealing with actually the maximum deflection. Okay, so we have here a simply supported beam, okay, of length 5 meters with a concentrated load 10 kilonewtons, okay, located 2 meters from the left support. So, yung mga points na to ay points A, B, and C. Okay, so drawing ko dito guys is yung most probably yung elastic curve niya. Okay, and then, sabi natin dun sa area movement method, gagawa tayo ng isang tangent line coming from one point. So, in most cases, nagguguhit tayo or gumagawa tayo ng tangent line from one of the support. So, just like this, okay, gumawa tayo ng tangent line from point A. Okay, yan na. So, again, the deviation of a point, okay, just like this one. If the point is above the tangent line, it is a positive deviation. So, since ito yung point C, okay, this deviation is, we will call this TCA, or the deviation of point C from the tangent line drawn at point A. So, ito yon. Okay? On the other hand, I would like to emphasize this, no? Ito yung elastic curve natin. Okay, at itong maliit na to, yun yung deviation ng point B with respect to the tangent line drawn at point A. At po, no, yan po yung kapiranggot na to. Yan yung deviation. Okay, whereas ito, from here up to here, tawagin natin tong B prime, no? Okay, ito po yung deflection of point B. Okay, so we discussed doon sa previous video natin yung about sa moment diagram by parts. So, ginawa na natin dito yung moment diagram by parts. So, actually, kahit saan naman tayo mag-fix. Okay, as long as it is convenient doon sa solution natin. Okay, so, first, syempre, kailangan mo makuha yung mga reaction. Okay, so since 10 kilonewtons lang naman ito, so 6 kilonewton to, 4 kilonewton ito. Alam niyo na kung paano yan, no? So, let's say nag-fix tayo sa point C. Ito, no? Nag-fix tayo rito. Okay, so ibig sabihin lahat ng forces na involved, okay, dapat may moment dito. So, just like this one, yung 6 kilonewtons. Ano ba yung distance nyo from point C? So, that is 2 plus 3. That is 5 meters. So, 6 kilonewtons times 5 meters is 30 kilonewton meter. So, positive siya dahil upward din yung application ng force. So, pag ganun siya, no? Kaya that's why ito yon. On the other hand, yung 10 kilonewton load ay 3 meters away from point C. So, 10 times its perpendicular distance na 3 meters. So, 10 times 3 is 30 rin. Pero pababa. Kasi pababa rin yung application ng load. Tandaan nyo yun, guys, no? So, 10 times 3 is 30. Negative 30 lang kasi pababa. And kung mapapansin niyo, yung 30 tsaka negative 30 pag pinag-sum up natin, that is actually equal to 0, which is actually the moment here. Moment at C equal to 0. Alam naman natin kung bakit, no? Kasi kailangan bumalik sa 0 yung moment natin sa sa support, no? Sa simply supported na status. Okay. So, this is our moment diagram by parts. Okay. So, yung unang tanong natin sa taas, for the beam shown, determine theta A. Okay. So, paano natin kukunin yung theta A? Okay. Nandito tayo sa solution natin. Na okay. So, if you notice, okay. Ito na. Ayan. Ito siya. Ito yun, no? Okay. For small angles, no? Actually, dapat ito, tangent theta A is equal to what? TCA over 5. Nasaan yun, sir? Okay, ito po yun. Ito yun, guys, no? So, tangent of an angle is equal to what? Opposite over adjacent. But for small angles, it is assumed that tangent theta is equal to theta itself. So, therefore, ito na lang yung in-assume natin. So, theta A, which is this one, is equal to what? Opposite na TCA over adjacent na 5 meters. So, we need to get the value of this TCA. And once we get this, divide natin ng 5 and tapos ang usapan. Okay, so what is TCA? Okay, or the division of point C relative to the tangent line drawn from point A. Okay, so ano nga sabi natin doon? Ito na tayo, no? Okay, so EI times TCA is equal to what? Area between A and C times the x bar or the distance of the centroid from point C. Okay, so we have here what? Ano yung una nating area? Okay, yung una nating area ay sa taas, triangle, which is 1/2 base times height. Alam naman siguro natin yan. Okay, so that is 1/2 times base times height. So 1/2 times 30 times 5. Ito yon. Okay, yung first part. Times the distance of its centroid from point C. So, alam naman siguro natin na ito ay 1/3 from or 1/3 of the base. So, since ang base natin ay 5, so this is 5 over 3. So, mas maganda na ginagamit natin yung sakto or yung fraction form niya. No? So, ito po yun. Ito yung 5/3 na to. Okay. And then yung nasa baba, this 1/2 base times height, but take note negative yung area nito kasi nasa ilalim. So 1/2 times 30 times 3, negative 30. Okay, so ito yung area. Okay, times the distance of the centroid from point C. 1/3 of 3 is actually 1. No, nilagay ko lang dito as 3 over 3, no? Ito po yun, no? Ito yung distance ng centroid niya, which is 1. Okay, so finally we have what? 125 plus negative 45 or simply 80. Divide na natin yung EI. So TCA is equal to what? 80 over EI. Then eventually, balik tayo ron sa formula sa taas. So TCA over 5. So TCA, which is 80 over EI divided by 5 is equal to 16 over EI. So yan po yung theta A. Okay, next. Ano yung sunod natin tanong? Sunod natin tanong is delta B or the deflection at point B. So if you notice here, okay, paano natin makukuha yung delta B? We need first the value of TBA. By applying ratio and proportion, okay, by similar triangles, no applicable yan. So TCA over 5 is equal to what? The sum of delta B and TBA divided by 2. Okay, so ito po yun. But actually, this quantity is actually what? Saan equal yan? Ito yan, no? Yun yung theta A. Okay? So, further simplification will yield to what? Delta B is equal to what? Okay, 2 times theta A, ito yon minus TBA, in which TBA is equal to what? Or EA TBA is equal to what? The area between points A and B times, okay? It's the distance of its centroid from point B naman. Okay, nasan yung area na yun, sir? Nasan po yung points A and B? Ito yung A, ito yung B. So, ito lang yung area na kailangan natin. Okay, mula rito, papunta rito. Okay, so ang distance ng centroid niya is 1/3 ng 2. That is 2/3. Okay, at ang area nito ay 1/2 base times height. So, 1/2 times 12 times 2. So, walang problema doon. Ito po yun. And ito yung 2/3. So, surprisingly, that is equal to 8. Okay? So, TBA is equal to 8 over EI. So, nakuha na natin yung TBA. Then, balik tayo rin sa formula. So, delta B is equal to what? 2 times theta A, which is 16 over EI. Ito yon minus TBA na 8 over EI. 32 over EI minus 8 over EI will yield to 24 over EI. So, the value of delta B is equal to 24 over EI. Okay, next. Doon naman tayo sa maximum deflection. Ano ba yung alam natin sa maximum deflection? So, pag sinabi maximum deflection, alam natin na zero yung slope doon. So, kapag gumawa tayo ng tangent line doon, sa location ng maximum deflection, okay, ang slope doon ay 0. Okay, so let us say that the location is arbitrarily at point D. Okay, so pag gumawa tayo ng tangent line doon, ito yun, maliit lang naman yun eh. Ito. Tatama yan doon sa isa pang tangent line na ginawa natin kanina pa. Okay, yun yung tangent line sa A. Okay. And sabi natin, yung angle between two tangent lines. Okay, so from point A to point D, or from point A and from point D, katawagan natin siyang theta AD. But actually, saan kaya equal tong theta AD na to? Okay, kung mapapansin ninyo, equal yan dun sa theta A mismo. Okay, na nakuha natin kanina pa. Okay, so kaya meron tayong conclusion dito. Ayun, theta AD natin is equal to what? The numerical value of theta A. In which, yung theta AD, kaya natin kunin yan, okay, by means of theorem number 1 ng area moment method. Okay, ito po yun. Okay, so hindi natin alam kung ano yung distance ng sentro, or rather, distance ng maximum deflection dun sa point A. So, tatawagin natin yung distance x. Okay, so since hindi natin alam yung magnitude nito, so 6 times moment arm na x, yun yung 6x. And then, so x ito at 2 meters ito. So, itong kapiranggot na distansya ng 10 doon sa point D ay x minus 2. So, we have 10 times the quantity x minus 2. Yun yung magnitude naman dito. Negative nga lang. Okay. So, let us solve for EI theta AD, which is equal to what? Area between A and D. So, asan yun? Itong area na to ay mas malaki, tsaka itong maliit na area na to. Okay? So, dahil inassume natin yung location, most likely, lagpas yan ng 10 kilonewtons dito banda. Okay, kailangan mapatunayan natin, kasi x minus 2 ito eh. Kailangan mapatunayan natin na yung x ay greater than 2. Okay? So, ano yung area nitong maliit na to or malaking to? 1/2 times 6x times x. So, ito po yun. Area lang naman tayo eh. Okay? And then, ano yung area ng maliit na to? So, 1/2 times x minus 2, ito yon, times yung height na 10 times x minus 2. Negative yon, no? So, ito po yon. 1/2 base times height. So, simplification or simplifying will yield to what? EI theta AD is equal to what? 3x squared minus 5 times the quantity x minus 2 squared. In which, kanina, yung theta A natin is 16 over EI, mas multiply lang natin. So, since EI theta A is equal to 16, equate natin ito, tsaka ito. So, meron tayong isang quadratic equation. So, solving for the values of x, dalawa yan, dahil quadratic equation yan, we have x equals what? 2.35425 meter, good for decimal places, and 7.64575 meters. Sabi natin, kailangan greater than 2 meters yung value ng x. Pero bakit ito yung sagot? Kasi, yung length ng beam natin ay 2 plus 3 na 5 meters lang. So, hindi pwede maging value yung x sub 2 dito. So, kukunin nating sagot dito ng x is yung 2.35425 meters. Okay. And what else? So, nakuha na natin ito, gagamit ulit tayo ng ratio and proportion. Okay. So, what is theta A actually? Okay, ito yun. It's actually equal to what? The sum of delta max and TDA, okay, the division of point D from the tangent line at point A divided by adjacent na x, nakakakuha lang natin. So, or cross multiplying, we have what? Delta max is equal to what? X times theta A divided by TDA, in which the value of TDA is set to find out. Okay, ito yun, no? So, ito na tayo. Gagamit tayo ng second theorem ng area moment method. Okay, so we have what? Ano yung area ulit nito? 1/2 times 6x times x. Ito yon. Yan. Times 1/3 ng x. Kasi yun yung distance ng centroid nito. Dito. Sa point B. Point D rather, no? Ito. And then, ito yun na 1/2 times negative 10 times x minus 2 times x minus 2. Yun yung area. Yun yung nasa taas kanina, no? Times 1/3 ng x minus 2. So, simplify muna natin. We have what? X cubed minus 5/3 of the quantity x minus 2 cube. Actually, kung mapapansin ninyo, kapag integrate mo to, ito no, kapag integrate mo siya, ito yun. Okay, ano ba integral ng 3x squared? X cubed. Ano integral ng 5 times x minus 2 squared? Ito, 5/3 times x minus 2 cube. Okay? So, substitute natin yung nakuha natin na value ng x, 2.35425. Okay, doon sa equation. Okay, so we are going to get TDA equals 12.9743 over EI. And substitute back here, so ito yung kailangan natin eh. Meron tayo ng x, saka nung theta A kanina pa, ayun na, 16 over EI. So by substitution, okay, we have what? 24.6937 over EI. So kung i-recall natin, yung delta B kanina ay 24 over EI, saktong-saktong 24. Ito naman 24.6937 over EI. So yun, ito po yung ating maximum deflection para sa beam na to. So kung meron numerical value yung EI, just divide it. Okay, just be consistent sa units. Okay? So proceed tayo sa next example. Okay. So, meron tayong pangalawang example dito. So, ito naman, meron naman tong overhang ngayon dito. Okay? So, this is a 10 meter long beam with a 2 meter overhang here under this loading. Okay. So, mahalaga na alam ninyo kung paano kunin yung reaction. Okay? So, pangalanan natin to na A, ito B. C naman ito, D ito. Okay, meron lang tayong konting problema dito. Actually, hindi siya konti. Medyo malaki yung problema natin. Okay, meron tayong discontinuous na load dito. Okay, na 20 kN per meters. Nakadistribute lang siya sa length na 4 meters. Okay, pero, di ba ang kailangan natin, mag-fix lang tayo sa iisang point. Okay, so, yung pag-decide kung saan ka mag-fix, medyo kailangan pag-isipan mo maigi kung saan. Along with the yung direction ng slope or yung tangent line na gagawin mo mamaya. Okay. So, we decided to fix at point D. Okay. So, paano po yun? Kasi nandiyan yung base ng triangle eh. Okay. So, ang ginawa natin, in-extend natin yung 20 kN per meter hanggang dun sa dulo. Okay. Pero dahil in-extend mo, okay, in-extend natin eh. Okay, babawiin mo sa ilalim. Para yung ginagawa natin sa double integration method. Okay. That's why, ito yung kanyang equivalent na loading. Okay, na hindi mababali yung original na loading. Okay, so by the way, is point A, lagay lang natin dito, is A, B, C, D. Okay, ang hinahanap dito yung deflection sa point D. Okay, this is 72.5, this is 97.5. Okay, so we decided to fix at point D. Okay, so ito po yun. Ito yung ating magiging equivalent na moment diagram by parts. Okay, medyo malala. Okay, so ibigyan ko muna ng emphasis itong moment diagram by parts. So, this is 72.5 times 10, that is 725. Ito yon, pataas. Okay, itong 20 kN per meter, that is what? 20 times 6 times 3, yun yung 360 dahil pataas. 97.5 times 2 meters, yun yung 195. So, lahat ng pataas na address na natin. Okay, lahat naman ng pababa. So, ito naman, itong buong ito, 20 times 10 meters times 5 meters, 1,000. Negative dahil pababa yung loading. Okay, a counterclockwise moment to 100 kN meter. So, bababa ka muna dahil negative to ay counterclockwise to. So, pababa muna, then akyat ng 100 ulit para bumalik sa 0. And then, yung 30 kN meter na to, okay, na triangular loading, paano naman po ito, sir? Okay, so 1/2 times 30 times 6, I think 90 yon, times 2, 180. So, ito po yun, no? Just take note of the degree of the function. So, yung uniformly distributed load sa taas is second degree, while yung para sa triangular loading, that is third degree. Okay. So, I indicated here, okay, important values dun sa kanya-kanyang moment diagram by parts. Okay, kasi tandaan nyo maigi, no? Post the video if you need some time, okay, to para ma-absorb, no? So, ito po yung ginawa kasi natin. Bakit kailangan natin to, no? Actually, before we proceed, ito yung mga computation ng area and yung kanilang centroid from point D. Ito guys, from point D. So, kung mapapansin niyo dito, lahat ng x1, x2, x3, x4, x5, x6, lahat galing sa point D. Okay. So, take note, diniscuss natin ito sa part 1, yung pagkuha ng area. Okay, 1/2 base height, base times height kapag triangle, 1/3 base times height pag second degree, 1/4 base times height kapag third degree. So, nandito lahat to. And then, 1/3 kapag triangle sa centroid, 1/4 kapag second degree, and 1/5 kapag sa third degree. Okay, ganito kasing ginawa natin. Ayan. Okay. So, kasi ito na yung buong solution natin. Okay, so gumawa tayo ng elastic curve. Ito yung pula, no? So, let us assume that, okay, nasa taas yung nasa taas ng original na beam yung deformed or deflected shape ng point D. Okay, so ito yung delta D natin. Okay, but since point D is above, okay, the tangent line, it is still a positive deviation. Okay, so, paano po natin ginawa ito, no? Kailangan natin ng dalawang deviations, TDA tsaka TCA. Okay, so that makabuo tayo ng similar triangles in such a way na we have TCA over 8 is equal to what? The difference of TDA and delta D. Kasi ito yun, no? So, ito yung tinutukoy natin, no? Ito yun. Ito yung TDA minus delta D. Okay? Divided by 8 plus 2 na 10. Okay, so ito po yun, no? Or solving for delta D, we have TDA minus 1.25 of TCA. Okay. Yung TDA, actually walang problema. Maikli lang yung solution ng TDA. Ito lang yon. Okay? Using the values na nakuha na natin kanina, kasi yung mga involved dito ay between A and D. Kung babalikan natin to, so yung point A tsaka point D, madaling kunin yan. Okay? Area ng buo times yung centroid from point D na nakuha na natin. Kasi sa point D tayo nag-fix. So, makukuha natin kaagad yan at ease. So, this is, okay, TDA is 2,836 over EI. Ito yung medyo madugo, yung TCA. Okay, paano natin kukunin yan? Kasi ito, between A and C lamang. Okay, times X bar sa C. Kaya dito, sa moment diagram by parts natin, kinuha natin yung mga values nito. Sir, paano po kinuha yung mga yan? Okay, example ko muna to. Okay, paano nakuha itong 160 na to? Okay, so nanggaling ito doon sa pataas na 20 kN per meter. So that is what? 20 times 4 times kalahati ng 4 na 2. So 20 times 4 times 2 is 160. Ito po yon. So nakuha itong 580 na to. That is 72.5 times moment arm na 8 meters. So 580 po yon. Okay. Saan nakuha itong negative 640 na ito? Doon sa 20 sa taas. Ito. So 20 times 8 times 4. Okay, that is 640. Ito. So ito wala naman tayong problema dahil all throughout negative 100 yan. At itong negative 160 over 3 na to, okay, saan galing ito? Galing yun sa triangular loading. Kaya kung napapansin niyo, meron dito 20 kN per meter, variation in proportion lang naman to. So ito 4 and 2, so 20 ito. Kasi every 2 meters, akyat siya ng 10. Okay. So, that is what? 1/2 times 20 times 4, ilan yun? 8, 40. Doon nagkakamali. O, 1/2 times 20 times 4, tama, 40. Times 4 thirds. So, yun yung 160 over 3. Okay? So, syempre, ito hindi nakasama to kasi C to D ito eh. So, kung mapapansin niyo, ang area lang na kailangan natin, ito, tsaka ito. Okay? So, this one is 1/3 times 160 times 4. Okay? This one is 1/2 times 580 times 8. This one is 1/3 times negative 640 times 8. This one is 4 times negative 100. And this one is 1/4. Okay, of 160 over 3 times 4. Ito lahat yon. Nandito sa next page. Ito yung una na. 1/3 times 4 times 160. Pangalawa, 1/2 times 8 times 580. Pangatlo, 1/3 times 8 times 640. Pang-apat, 4 times negative 100. At yung panglima, 1/4 times 4 times 160 over 3. And these are their corresponding distance of the centroid from point C. Okay, take note. From point C, 1/4 ng 4, 1/3 ng 8, 1/4 ng 8, 1/2 ng 4, at 1/5 ng 4. Okay, kasi ito, second degree. Second degree. Third degree, divide 3, divide 4. Ito, triangle. So, 1/2, 1/3. Ito, second degree. Kaya 1/3, 1/4. Ito, 0 degree. Kaya over 1. At tali ito, over 1. Ito, over 2. Ito, third degree, over 4, over 5. Okay, so, ang makukuha natin dito ay 2,144 over EI. So, kailangan mo lang tsagain ito, no? And then, by substitution, sa formula natin kanina, na ito, no? Yan, ito. Okay. So, 2,836 over EI times 1.25 times 2,144 over EI, we will get 156 over EI. And that is positive, actually. Okay, ano ibig sabihin ng positive? It means that the assumed direction of D prime is actually up, or that delta D is actually upward. Tama yung assumption mo. But kapag inassume mo pababa, papunta rito, definitely negative yung makukuha mo. Okay? Mababalidate natin yan kasi, ayun na, yung TDA natin, 2836. Okay? At yung 1.25 TCA is mas maliit kumpara sa 2836. Okay? So, ganyan po yung paggamit ng moment or ng area moment method. Okay. So, ayan na guys, no? Ganyan lang naman kasimple. Okay. So, I think meron tayong part 3. Doon natin i-address kung paano kumuha ng deflection, tsaka ng slope sa cantilever beams, tsaka yung mga iba't ibang values ng moment of inertia. Doon natin ma-address yun sa part 3 ng ating video lecture series. Okay, so shoutout nga pala kay soon-to-be engineer Jason Mejia. Okay, na nagpapa-shoutout. And sa mga kasamahan ko sa Falcon Engineering Review Center, Engineer Francis, Engineer Jercel, Engineer Gestoni, Boss Isaiah, tsaka sa JR, Sir Ivan Marquez, okay, sino pa ba nakalimutan ko? Okay, so Sir Eman, Evangelista. Okay, so yun yung mga, ano natin, yung mga Falcon lectures natin. Okay, so, okay, so God bless guys, no? Thanks for watching, then please stay tuned for part 3. Okay, thank you guys, thank you.